So in this section, pretty much just saying that the method can be a generic method, right, for a static method. Like, we already know the concept of statics, that this method can be shared, right, among the objects with public and statics. Then you can access the method by just call. You don't have to instantiate, just say instance class name dot, right? Now the benefit of this generic method is we put a bracket in front of the method before the type method name here. So we have to say e with, we can print any arrays with any types. So when we call the method, say generic method demo dot, we can say integer. We just give a concrete type string and print. Then we don't have to reinvent the method for each data type to print each different types. So when we declare a generic method, you have to place it immediately after the keyword statics, okay, in the header, method header. To invoke, you require to put a prefix, right, the method name, and give the actual type in the angle brackets. And this is a prefix of method name with the actual type. A generic type can be specified as a subtype of another type, such as generic type is called bounded, like we talk about here, E extends, subtype of geometric object. So this is called bounded generic type. We may never seen that. This is the first time we see, like in the program B extends geometric object. So we do this, like for example, we're gonna have test, right, whether two geometric objects have the same area. In the test geometric object we want to see, and we're going to revise our code for the equal areas, right? We have seen the code. So let's look at, so we create the static generic methods, right? And we said we have the method equal area, right? And we provide two objects, E1 and E2. So in the main we create rectangle and circle. So rectangle has the way to create like the areas and circles, right? This is side by side, this is pi r square. Now we wonder if they have the same area. So we create a method named equal area, right? And we have to do bounded generic type here, so that these two instances that we compare, there's instances of geometric object. Like we don't want to compare any other type, integer, double. If we just do E, it's going to make it compare to those types. So that's why we have to do E extends geometric object. Only these two types that we can do compare equals areas. And then we can call object1.getArea, object2.getAreas. If the equals, it returns true, otherwise false. And this is already implemented, right, from the previous, when we do inheritance extends and doing the first for the get area. So that's the benefit of bounded, right? We call bounded generic type. we can look at a case study to sort an array of objects. You can use a generic, right, to help generic method, right, an array of comparable objects. So sort. So for example, we can sort an integer, double, and character and string. How are we going to make one sort to sort everything? We just make it as a generic sort method, right? Static x, e, and we want to make sure that we don't want to sort everything that never implements compatible, so we just do the bounded generic type, which is e extends compatible e. Then in this case, only the object that implements comparable can be using the static sort, right, generic sort method here, and then we can sort any data types. This is the same logic that we have how to sort. Okay, but we just make it the method more generic and use the bounded generics to make sure only the one that's compared to can use it. So raw types and backward compatibility. A generic class or interface used without specifying a concrete type. So if you don't specify the concrete type, it's just like you instantiate and you don't put a angle brackets, which is equivalent to you specify an object as type, concrete type, and this is called raw type. Okay, when you do this, it enables backward compatibility with earlier version of Java, because earlier than 1.5 they do not support generics, so they use only object. Okay, so using raw types allow for backward compatibility with earlier version of Java. Let's say, for example, max class, we have static comparable, max comparable, object 1 and object 2. Object 1 dot compare to object 2 greater than 0, return 0 object 1, otherwise return object 2. So comparable O1 and O2 are raw type declaration. Be careful, raw types are unsafe, so you don't want to do raw type. It's unsafe because, let's look at this example, max.max. Here this is string and this is integers, and they're objects. They still allow it to use max method here to compare, right? And 23 here is pretty much just even its primitive type is get auto boxing to an integer wrapper class become an object type, and this would cause what? A runtime errors. That's why generics help. The benefit of generic is what? They take the errors as compile time, so you don't let the user experience that issues because you compare different type. Right, its type is unchecked. Unchecked call compare to as a member of, that's an errors. So use the raw type is not safe. So to modify that, we just make max using generic type class and do e extends comparable, use the bounded generic, right, type. Now we can make sure that it has to be comparable, one thing, and has to be the same type to compare. Like now this is going to have a compile errors, not runtime errors, which is better. Now, wildcard generic types. You can use unbounded wildcards, bounded wildcards. So we talk about bounded, right, and unbounded, like the extents, right? Now we have lower bound wildcards to specify a range for a generic type. So let's look at what's this. So what are wildcard generic types are and why are they needed? Look at this example. So we create a generic stack, right, and integers. Push 1, 2, those are integers, right? Minus 2. And we say the max number is going to call max. Max is a generic stack, number stack. So we can pretty much just pop, right? Pop. So stack, we have pop is return the max values or the top, right? Which is double values. We just get the double values, make it to double max, because it's going to pop the numbers. And the numbers now we push into integers, so we have to do dot double values to change it to double. So, and we can see this is a number, right, instead of integers, right, when you put max. So this is pretty much just a parent, number is parent, so it's fine to do that, right? And then we just loop to find the max. But if you look at this, it's going to get a compile errors in line 8. You may thought that this is fine to do that number, but it's not, because generic check the type, right? I'm looking for an integer, not a number. You may thought that because the parent is of the number is integers, the parent of integers, parent class is number, it's fine to do that, like polymorphisms. No, we cannot do that. It's going to get an error. So that's why we need help. So you cannot invoke max in stack, right? Because type number. The fact is that integer is subtype of number, but generic stack integer is not a subtype of generic stack number. That's why it's not allowed. So to solve this problem, use wildcard. So wildcard is the benefits now. So there are 3 forms of wildcards: question mark extends t, and question mark super t, where t is a generic type. So question mark is a wildcard called unbounded wildcard. So if you want to do bounded, just question mark extends the object. Alright, the second form, question mark extends t, which is called bounded wildcard. And t represents t or a subtype of t. So the question mark super called a lower bound wildcard. So t denotes supertype of t. Now we can fix the errors by changing this max generics. Just say wildcard extends number. Now we have no problems because it's about it. So we know that any type that extends number we can use now. Integers should be fine to call now, right? Max in stack, because we have wildcard extends number. So a wildcard type that represents number or subtype of number, so it's illegal. It is now legal to invoke max generic integers or max new doubles. We can see this is another example. This is unbounded wildcard used in the print. So if you want to print, then you can print any type, integer type, right? Double types. And this is another example of using wildcard with a super. This is lower bound. So when is the wildcard or the lower bound used? Look at this example super wildcard demo.